Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study how to draw a cam profile when the roller follower is having a motion of simple harmonic motion during outstroke and inward stroke, return stroke, but the axis of the follower is offset by 20 millimeters or 15. We can tell that here we are considering it is offset by 15 millimeters from the axis of the camshaft. In the previous session, we have covered how to draw a cam profile with the same data for a case study of when the axis of the follower is passing through the center of the camshaft. That is the case study A. That means the line of the stroke of the valve rod passes through the axis of the camshaft. But in this, we are going to study the second case study. Okay, and here we have to see how to draw a displacement diagram for a simple how to draw a displacement diagram when the follower is having simple harmonic motion. Now a cam with a minimum radius of 25 millimeter rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of a valve rod motion described below. To raise the valve through 50 millimeter during 120 degrees of rotation, 120 degrees of the rotation of the cam, to keep the valve fully raised through next 30 degrees, and lower the valve during the next 60 degrees, to keep the valve closed during rest of the revolution, that is 150 degree. So the diameter of the roller here it is 20 millimeter and the diameter of the camshaft is 25 millimeter. Draw the profile of a cam when the line of the stroke is offset 15 millimeter from the axis of the camshaft. So the displacement of the valve while being raised and lowered is to take place with a simple harmonic motion. Determine the maximum acceleration of the valve rod when the camshaft rotates at 100 rpm. Draw the displacement, the velocity and the acceleration diagrams for one complete revolution of the cam. So here there are two types of certain terminologies are there. Instead of saying that outstroke and return stroke, here the outstroke is mentioned to raise the valve through 50 millimeter, to raise the valve through 50 millimeter during 120 degree rotation of the cam. This the valve 50 millimeter to raise, this 50 millimeter is the stroke of the follower, and 120 degree cam rotation of the cam is out to stroke, that is 120 degree to raise the valve. Next, to keep the valve fully raised through next, this is theta outstroke dwell, theta OD. To lower the valve during next 60 degree, that is theta return. And again to keep the valve remains rest for next one, that is theta return dwell, return stroke dwell. So the angles were mentioned here. You can see here certain things how to draw. So take a scale of 20 degree equal to 1 centimeter. We have to draw a displacement diagram, that is simple harmonic displacement diagram. Further we have to take a scale, the scale on x-axis. X-axis we consider the rotation of the cam, and the y-axis we consider the lift of the follower. The rotation of the cam is in terms of angles. That angles is converted into the linear scale by assuming the scale conversion. The scale conversion factor is that 20 degrees of cam rotation, that equal to 1 centimeter. Then theta outstroke, theta O, that is 120 degrees that means it becomes 6 centimeter. Then theta outstroke dwell. Theta outstroke dwell, that is 30 degrees. The 30 degrees means 30 by 2, 3 by 2, 1.5. That is 1.5 centimeter. So theta return during next, that is 60 degrees. So theta return equal to 60 degrees. That equal to 3 centimeters. Theta return dwell, that is 200 and 150 degrees. That is 150 by 20. That is 7.5 centimeters. So we have to draw for the length of the square with this dimension. So this is the theta outstroke. AS represents theta outstroke. That outstroke is called theta outstroke theta O. Then it is theta outstroke dwell. There is theta return dwell. So here that is what valve raised, dwell, valve lowered, and dwell. So here AS is 6 centimeters or 6. The length of this one is 6 centimeters. And this is 30 degree, 1.5 centimeter. And again return stroke, try length. Even though we have mentioned here outstroke, return stroke and dwell angles, we mentioned here. But this is in terms of, these values are in terms of centimeters. So outstroke is 6, there is 1.5, again return stroke. Return stroke is how much? The return stroke is 3 centimeters. The length, that is T to P, length of 3 centimeters. And again P to X, length of 7.5 centimeters. So draw a line with the help of the scale. And draw on the axis. There is a vertical line, y-axis line, that is 50 millimeter. So draw complete the x and y axis. Okay, rectangle box. Now it is a SHM motion. The SHM motion line is how to draw the SHM displacement curve. Okay, take y-axis length, draw a center line, and off of this 25 millimeter, draw a semicircle. Okay, this semicircle. So divide this. Before that, divide this outstroke and return strokes into even number of parts. Even number. This even number can be 4, 6, 8, 10 and 12 or 12. So the optimum is a 6 number of parts. So it is easy. If it is 4, less accuracy. If it is 2, more, less result. Okay. And more accuracy, more number of parts, but it takes more time. So the optimum even number of parts are 6. So after that, what to do? Next step is that divide this even number of parts. Here even number of parts, outstroke is 6 and return stroke is 6. So outstroke equal number, even number, and mark with A, that is indicates as 0A, 1, 2, 3, 4, 5, 6. Draw vertical lines. Okay. Similarly, return stroke also draw vertical lines. Next what to do? Divide the same equal number of parts, this semicircle also. That is 180 degree, 6 parts, that is 30 degree each. Divide this and join the lines. Then draw a horizontal lines from, mark it with A, B, C, D, E. A, B, C, D, E. Then draw horizontal lines. A interacting with 1, this is the point 1. Next, that is a B. Horizontal lines, it is the C, and it is D, and it is E, okay, F, and it is G. Similarly, passing the same points. Okay, now with this same points you pass on to the curves here and the outstroke also. So after marking those points, you have to join those points with a line. Then it becomes a curve, that is called displacement curve. Okay. So now join this A, B, C, D, E, F, G, H, J, K, L, M and P, and it is P to X. This curve is the displacement curve, that is SHM curve. Okay. So again, what is the step 1? Draw a x-axis line. First scale. Convert this outstroke, return stroke and dwell angle of rotations of the cam, convert into linear scales. Then take x-axis, that x-axis, draw the lengths, draw the straight lines with those outstroke angles and dwell and return stroke angles. Then draw a vertical line, that is lift of the follower, that is 50 millimeters. Then draw a rectangle, complete the close. Then divide this one of the side of the return outstroke portion, that is a straight line, into semicircle. Then semicircle should be divided into even number of parts or same number of parts which are divided already, the outstroke and return stroke. Then join a horizontal line and that draw a vertical lines with the partitions. Then those intersections gives the displacement tracing points of the follower. Then after that, join these points A, B, C, D, E, F, G, H, J, K, L, M and P, P to X. This curve is the displacement curve when the follower is moving with simple harmonic motion. Then what to do after that? After this finishing, we have to use, that is the displacement curve. Okay. Then when the axis is passing through, so I am going to show you here. When the axis is offset by what? How much it is offset by? Offset by, they mention here, that is 15 millimeter offset. That is the case study we are going to study now here. Now, this is the curve just now we have drawn. That is the SHM curve. So these are the vertical displacements. When the cam is rotating 120 degree, is the near initial, this is a contact point with the base circle or minimum radius of the cam. From that the roller is moving. Our cam is rotating some, what is how many angle? This 120 degrees, 6 for 20 degrees. For 20 degrees of rotation, this one moves to B. This follower lifts at A initially at this point. Then it goes to, when the rotation of the cam is 20 degrees, the rotational, then it lifts up to point B. Next to point C, next to point D. For every 20 degrees add in, the lift follower will be lifts. So for 120 degree rotation, the follower lifts maximum of 50 millimeter, that is 5 centimeters, it will move down. Then what is the dwell outstroke? That is 30 degree rotation of the cam, it is the same position. Then return stroke. During return stroke, the valve will be closed lowered for the next 60 degrees. That is called a return. There is theta out, theta return, theta outstroke dwell, theta return dwell. Okay, that's what in this terminology: valve raised, dwell, valve lowered, and dwell. Now the point is that how to draw cam profile for the offset follower. The offset by it is 15 millimeter. The radius of the cam, what is the minimum radius of the cam? As mentioned here, what is the minimum radius of the cam? Minimum radius of the cam is 25 millimeters. Okay, the diameter of the roller is 20 millimeters. and the diameter of the camshaft 25. So roller dia is 20 millimeters. Diameter of the roller is 20 millimeter. Offset distance is 15, and minimum radius of the cam is 25 millimeter. Then what to do? How to draw? The procedure it begins. First to draw the minimum radius of the cam. That is, I am drawing. That is 25 millimeter radius. Join. This is the 25 millimeters. Then this is the center. Draw a offset circle. The offset circle is how much it is? 15 millimeters. Is a 15 millimeters offset circle. Draw 15 millimeters offset circle. So next, draw a axis line, offset tangent line, and with this line, take a distance of the roller. What is the radius? The radius of the roller, diameter of the roller is 20 millimeter. That is half of by 2. That is 10 millimeter center of the roller from this axis. 10 millimeter. This is the roller position now here. And draw another circle, that is called prime circle. Passing through this circle, this is the prime circle. Join the center of the offset circle to the center of the roller. This is the reference. Now with this 120 degree cam rotation, draw a line of 120 degree. So I have drawing approximately, it will be around 120 degree. This is theta outstroke. Next 30 degrees, theta dwell, outstroke dwell. Next is 60 degree. This is return stroke, and remaining is return stroke dwell. So divide this prime circle into 6 number of parts, even number of parts, 6 parts. This 120 degree, that means each point again how many? 20 degrees. Then only 6 parts will come. So give your points. This 1, 2, 3, 4, 5, and it is 6. This is the shape. The cam profile, the red color represents the profile of a cam. So here, one thing you have to do it here, we have to draw we have followed here, we made that, we have drawn the radial lines. One should not draw the radial lines. The mistake is that here we followed all radial lines as if we are following the lines following through the tangential, following through the radial lines. We followed the case study of when the axis of the follower is passing through the radius of the cam. But no, we have to follow the tangential lines you have to draw. The tangential lines, as if here mentioned, these tangential lines we have to pass through the markings of the divisions of the circumference of a prime circle. Through that line, it has to pass through it. These tangential lines should pass through it. Then it passes through, when it passes through the tangential lines here, on those lines you have to mark the distances 1 to B, vertical distance. This 1 to B and 2 to C, and this is 3 and it is D, 3 to D and 4 to E. Generally we follow radial lines. That is the mistake I have shown here. But we have to draw the tangential lines to the offset circle. Okay, tangential lines to the offset circle we have to follow. Similarly, the initial contact may be on the offset circle, whatever position may be. But when we are drawing on the circumference, but the radial lines, the tangential lines of the offset circle should pass through the intersection divisions. This is the division. This is the return stroke division up to here. 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So these tangential lines should pass through these lines. Okay, sorry, we made mistake. Now here on those tangential lines, you have to mark the distances from the displacement diagram. You have to mark that what is the distance, sir? 4 to E, 5 to F. This is the 4 to E. The distance from 4 to E is same as the displacement 4 to E vertical distance. Similarly, 5 to F. This is the 5 and F. Next is 6 to G. That is S. Mentioned here. S to G. After dividing and marking, these are the centers. The centers are A, B, C, D, E, F, G, H, J, K, L, M, N, P. So at point A, already we have drawn roller. At point B, center. At point B, draw a roller. At point C, which is the diameter is 20 millimeter. At point D, at point E, at point F, at point G, at point H, at point F, at point K, at center. Like that we have to draw. The intersection of the rollers may be completely mixing. Then after the intersection, the surfaces of all the rollers we have to draw. So the surfaces of all the rollers is okay. Now the surface of the rollers I am drawing here. It is pink color. It is smooth curve. This curve indicates the profile of a cam. Okay. So don't repeat, we'll forget. I made mistake in drawing the radial lines you have drawn. That means I followed this for the case of when the axis of the follower is passing through the center of the camshaft. But whereas in the case of offset, we have to draw not radial lines, tangential lines passing through the division markings on prime circle. So on the tangential lines, we have to mark the vertical distances has to take from displacement diagram and mark it on these tangential lines. Those distances points, again markings, those points are here A, B, C, D, E, F, G, H, J, K, L, M, N, P. Those again we have to draw through these points as centers of rollers. After drawing the center of the rollers, we have to draw a curve touching the surface by touching the surface of all the rollers. That curve denotes the profile of a cam, and this is the shape of the cam for the given conditions. The given conditions are the roller follower is moving with SHM motion, simple harmonic motion during outstroke and return stroke. It remains the same. And the outstroke angle is 120 degrees. Next to the outstroke is 30 degrees 12. and next to the dwell is return stroke, that is 60 degrees. Next to the return stroke, it is remaining angle, that is 150 degrees is remaining dwell. Here mentioned as valve raised for 120 degrees of cam rotation, 30 degrees remains open or remains raised, and again 60 degrees valve is falling, coming down, lowering, and it is remains lower for next 150 degrees of cam rotation. So the total angle of cam rotation is one rotation, that is 360 degrees. This is the cam profile. Okay. So be careful not to draw a radial lines for offset circle, which I have mentioned, explained completely. But after seeing the results, I got to know that no. So the point is that one should be very cautious. But for offset, we have to draw a tangential. Okay. That is what, and this circle is the offset circle. In this offset, there are 3 circles for cam you have drawn in order to do it, apart from the roller circle. That is, one is offset circle, another one is a base circle, and third one is the prime circle. Prime circle is, base circle is required in order to attach the dwell. Dwell curve comes to base circle, touches. For prime circle are highly important because through the prime circle only, from offset circle to prime circle division markings, this tangential lines goes. That's why all circles are important. There are how many circles are we are going to use here? We used here, one is offset circle, another one is base circle, and third one is prime circle. After the radial line, after the tangential lines, these vertical distances from displacement diagram marking on the tangential lines, those markings are centers of roller. Okay, the curve which passes through the surfaces of the all rollers, that curve is known as cam profile. That is the spot, that is offset cam profile with roller follower. Now here, very important is that for maximum acceleration of the valve rod, the angular velocity, that is, it is rotating by n equal to 100 revolutions per minute. So omega equal to 2 pi n by 60. 2 pi times n, 100 or 100 by 60, that is 10.47 radians per second. Then for maximum velocity, for improving maximum, the formula is that for SHM motion, pi omega s by 2 times theta o, that is outstroke. What is the s? Lift of the follower, that is 50 millimeters, that is 0.05 meters. Pi into, substitute here those values in this equation, in this formula, that is pi omega s by 2 times theta naught. Pi times omega 10.47 radians per second, 0.05 meters, 2 times theta o. That 120 degrees converted into radians, that is 2.1 radians, that is 0.39 meter per second. Similarly, during return stroke, in the place of omega remains same, s is same. In the place of theta o, outstroke angle, return angle, you have to substitute. That is pi omega s by theta r. Pi times omega 10.47 r, omega s is 0.05 by 2 times theta r. That is, r return stroke is how much? 60 degrees. In terms of radian, that is 1.047. After substitution, we calculated the value of 0.787 meter per second. This is the maximum velocity of the valve during raise of the valve and maximum velocity during lower the valve. And coming to acceleration components, the acceleration A naught, that is called dv by dt. If we make it pi square omega square s by 2 times theta naught whole square. Substitute here or here those values, known values. Pi omega s theta naught, that's theta naught is 2.1, that is 6.13 meter per second square. Next, maximum acceleration during return. In the place of theta o, substitute here theta r, that is pi square omega square r by s by 2 times theta r whole square, then 24.67 meter per second square. Here we have to understand the values, the relationship velocity diagram. Vr is proportional to the s and inversely proportional to theta r, and it is omega square and theta square is inversely proportional to theta r square. Acceleration is inversely proportional to, okay, and acceleration during return, theta r is inversely proportional to theta r square. So it is inversional, but the equation is not a linear. It is the non-linear equation. We can see these are the curves, how it comes. Okay, velocity equation with the angle of rotation, that is 0.39 during outstroke 0.39, and return stroke of the cam rotation, that is how much? Velocity diagram. This is the displacement and this velocity. Similarly, acceleration diagram, how it is increasing 6.13 and reduces to at middle of the angle 0, again comes down negative. This is the shape of the curves. These are the acceleration curves for 6.13 meter per second square during outstroke. It is due to during outstroke, and velocity during outstroke, and acceleration during return stroke, theta r, that is 24.67 meter per second square. So these are the velocity, displacement, velocity and acceleration diagram. Okay, so very important is that we have completed in this the case 2. So we applied for offset circle. We should be very careful that not to draw the radial lines. We have to use the tangential lines from the offset circle to the prime circle, passing through the divisions. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.